All right, so what we are going to be doing today is we're going to be doing the review for Unit 8 test. We're not going to do every problem, but these are the ones that you guys have to do. So let's go ahead and start. So this first one is about variation and inverse variation. It says if y varies inversely as x, so we know that is this equation, y is equal to k divided by x. And it gives us another hint. It tells us, what if x and y are equal to these values in particular? So we're going to go ahead and plug those in. So we know y is 8. We don't know what k is. And we know x is 2. Now, I want to get k by itself, so what I'm going to do is I am going to multiply 2 on both sides. I cancel these out, so I am left with k is equal to, 16. With this information, this k, I'm going to plug that back into my original equation, so I'm now going to have y is equal to 16 over x. Then it tells us, hey, now that you know this information, what if we plug in y? What is going to be my x? What if I plug in this value for y? So I go ahead and plug it in. And I want to find x. So I don't know if you guys remember our little trick. We said the easiest way to find out what x is if we have everything, all our values are put into our equation, and the value that is unknown is down here in the denominator. All we have to do is switch these two values. This is our trick, and now we have 16 over 5. I don't need you to simplify it or anything like that. This is pretty as it is. Oh, I was about to say, any questions, but leave a comment down below. I don't know. We'll figure this out. All right, let's try another one. If y varies inversely as x, and we want to know these two values. What is y 3 and x is 2? So we plug in those values. I want to know what k is, so the way I'm going to do that is by multiplying a2 on both sides to get rid of this 2 fraction. And I am left with 2 times 3 is 6. Go ahead and plug that into our previous equation. So y is equal to 6 over x. Find y when x is 8. Well, that's an ugly circle, but we're going to move on. So what if I were to plug in 8 for x? So I'm going to have 6 divided by 8. Well, I already have y by itself. So all I have to do is kind of just simplify. So they're both divisible by 2. So we are left with 6 divided by 2 is 3. 8 divided by 2 is 4. Pretty simple. Now we're going to do inverse variations with word problems. So read it first. It says the pressure of gas is at a constant temperature, varies inversely as the volume V. If the volume is 450 inch cubic, when the pressure is 30 pounds per inch squared, what is the pressure when the volume is 750? Again, this is a compare and contrast. So let's take a look at that very first thing. It says pressure of gas, constant temperature, varies inversely for volume. So pressure varies inversely to volume. It is always going to be K. Remember, no matter what letters we have here, T, S, K, whatever, these are our values. And it tells us, hey, what if the volume is 400 when the pressure is 30? I'm sorry, 450. So let's plug this in. V is for volume, so I know I'm gonna plug in 450. And pressure is 30. So I'm just color coding here. I want to know what that K is, right? So I'm going to go ahead and multiply 450 on both sides to cancel it out. And I know all of you guys have a calculator right next to you. So 450 times 30 is, thank you to that one person who got a calculator, 13,500. I'm going to plug this back into my equation over here. Remember to use P and V. All right. Again, it tells us, find the pressure when the volume is 750. Oop, I wanted to write all that, but okay. So I just have to plug in volume. It told me my volume is 750. And I want to know what P is, so all I have to do is plug everything in, plug this into a calculator. P is going to be 18. 18 what? Pressure is pounds per inch squared. Let's take a look at the next one. It takes Mario 5 hours to complete a task. It takes Luigi 3 hours to complete the same task. How long would it take if they were to work together, right? We've done this before. Hey, oh, it's Mario and Luigi. Oh, how funny. So we've done this before. Mario takes 5 hours to complete a task. So for one task, it takes him 5 hours. For Luigi, it takes him 3 hours to complete this task. Right? I want to know how much it would take if they were to work together. This X is them working together. This is what I want to find out. This one is this one task. These values down here are the times, so the hours. So what I want to do is I want to get all of this the same denominator, the LCD. So I'm going to go ahead and rewrite it right here. So what I have to do is multiply by every other denominator. So this X is missing a 3 and a 5. A 3 and a 5. And what I do to the denominator, I do to the numerator. Still haven't gotten the field. Same thing here. I am missing a 5 and an X. That would be my LCD. So I'm missing a 5 and an X. Numerator and denominator. And last, this first fraction, a 3 and an X, a 3 and an X. Excuse me. So multiplying everything together, this first fraction, 1 times 3 times X, 3X, 5 times 3 times X, 15X. Second fraction, 1 times 5 times X, 5X. 3 times 5 times X, 15X. 1 times 3 times 5 is 15. 3 times 5 times X is 15X. Do we have the same denominator? Yes. Oh, no, that's smeared. Yes, we have the same denominator. So what we are now going to do is we're going to focus on the numerator. So we have 3x plus 5x is equal to 15. Remember, the goal is to get x by itself. So I could combine like terms. 5 plus 3 is 8. So 8x is equal to 15. I want to get x by itself, so divide by 8. So I am left with x is equal to 15 over 8. we could make that a simpler term. I'm going to 15 divided by 8 is 1.875. Now, what is this? Hours, task, days, hours. Make sure you write your unit. So Mario takes 5 hours, Luigi takes 3. If they were to work together, it would only take them a little bit less than 2 hours to do. All right, let's move on to the next one. Chandler can mow his yard for 4 hours. When Monica helps, it takes them 3 hours to mow the lawn. How long would it take if Monica were to mow it by herself? Is this like from Friends? Chandler and Monica? I don't know. So we have Chandler. We know for a fact he can do it in 4 hours. Okay, cool. He can do it in 4 hours. But then they say, hey, when Monica helps, so when Monica helps Chandler, so both of them together take 3 hours. We want to know how long would it take for Monica, just Monica, to do that. So this is how we set that up. Chandler plus Monica is equal to them together. Do we see this? Great. So we're going to rewrite it right here. I want to know what that x is, so I'm going to start figuring out how am I going to get all the denominators alike. Oh, I wrote this wrong, but we'll be fine. That is an x. So again, just like in the previous one, I want to get the same LCD. So this 3 is missing what from its LCD? 4 and x. Numerator and denominator, what you do to the top, you do to the bottom, all that jazz. This x, I'm missing a 3 and a 4. And this 4, I'm missing a 3 and an x. So now multiply everything together. 3 times x is 3x. In the denominator, we're going to have 3 times 4 times x, 12x. Plus 4 times 3, 12. 4 times 3 times x, 12x. And then the last 4 times x is 4x, equal to 12x. We have the same denominator, so we are able to just focus on our numerator. So we have 3x plus 12 is equal to 4x. So what I'm going to do is I'm going to combine like terms, right? But like terms are on opposite sides. So minus 3x on both sides. This cancels. So I am left with 12x. Oh no, 12 is equal to, ignore that. 12 is equal to 4 minus 3 is 1x. You can divide by 1, but that's not necessary. So we say x is equal to 12 what? Hours. So it takes Monica 12 hours to do this. So she mows the lawn really slowly. What? Oh my God, whatever. So moving on. Number 5, an amusement park offers a family discount package for an unlimited number of rides and will charge an entry fee for each person in the family. The equation c of x is equal to 120 divided by x plus 7.5 represents the cost per family in c of f of x as a function of number of people in the family. If each person in the family paid $17.50, how many people were in the family? So x, right here, this x is representing what? The number of people, right? And then c of x is representing the cost of each person. So this number right here, we are going to, well, let's first write our equation. C of x is equal to 120 divided by x plus 7.5. So what I want to know is, hey, I know this number right here. I paid $17.50. This is money, so this is the cost. I want to know X, how many people were in that family. So I'm going to go ahead and plug that value in. This 1750. Right? I want to know what X is. So pretty simple. Let's go ahead and move this 7.5 over. So we are left with 10 is equal to 120 over X. So remember our trick from before up here? We had all our values put in except for the denominator that X was missing, so we're going to be able to do that same thing right here. So bringing this up here, we have X is equal to 120 over 10. You can drop those zeros, so X is equal to 12. 12 what? People. 12 people were in that family. Okay, let's move on. This video is going to be pretty lengthy, so okay. Find the vertical and horizontal asymptotes for the graphs of the given rational functions. So we don't have to actually plug in anything or try to figure out what all this is. What I want you to do is just highlight what is my vertical and horizontal asymptotes. So vertical, pretty self-explanatory, is up and down. So the vertical asymptote is at right here. Oh, that is a crooked line. Right here. So that is at what value? At X equals 1, 2, 3. At X equals 3. Vertical asymptotes are X values. Horizontal asymptotes, again, flat on its stomach, is going to be right here, where it is approaching these two lines. So that is at Y equals -2. Sorry, that was crooked. So just for kicks, let's go ahead and say a couple of extra things about this problem. So when we have a vertical asymptote, we know the domain is everything except at that vertical asymptote. So X except at 3. Right? Because if we look at all of our X values, it never touches 3. It touches every single X value. What about range? Same idea. Touches every Y value except at that horizontal asymptote, except at -2. So that's one thing you could also say about it. Another thing is, hey, these values are also our H's and K's. So H is our vertical asymptote, right? How much it moves to the left and to the right are our vertical asymptotes in our graph in general. So this is 3, and it moved 3 to the... Wow, I'm expecting an answer. I don't know. It moved 3 to the left. Oh, wait, sorry. Whoa. Man, I expected an answer. I should have gotten an answer because I was wrong. That is 3 to the right. Whoops. Yo, we'll be fine. And then our K, remember, that is going to be at -2. That means we are going to down. If you need a recap of what I am talking about, remember our function, our parent function is Ax minus h plus k. H is going to tell you left and right. It's the opposite. And k is going to tell you up and down. Just another piece of information. Let's go ahead and do that same thing with this value, number 8 right here. Our vertical asymptote, it never touches what value? At x equals -5. And our horizontal asymptote, our graph never ever touches and approaches y equals 1. Domain is at every value except at our vertical asymptote, -5. Range is at every value except at our horizontal asymptote, 1. H is -5, which is going to the left, as we see clearly, to the left. I didn't see it before, clearly. And K, it is going 1, and that is up. Remember, if it's positive, it's going up. If it's negative, it's going down. If it's negative for H, it is going to the left. If it's going to the right, it is a positive. All right, let's move on to these 4 right here. We're actually not going to do number 12, so if you want to scratch that out now and not even look at that, go ahead. So now we're going to be doing a series of questions per function. So we're going to do it out of order because it makes a little bit more sense to do that. Vertical asymptote. My vertical asymptote is my denominator equal to 0. So that means my vertical asymptote is at 4. This is going to tell me right away, hey, my domain, it's going to be everywhere except at the vertical asymptote. So I'm going to go ahead and write not at 4. So if you need a template, it's going to be x except at my vertical asymptote. There's no range, but if we wanted to rewrite this one, we're not doing holes. Range would be y except at horizontal asymptote. Our horizontal asymptote is our Betsy Bobo Boat2. So in the back of your paper, let's go ahead and start writing that now. So let's write it in black. So Betsy Bobo and Boat2. All right, doesn't all fit, but we'll get to it. So Betsy, remember, bottom equals top. This is our coefficients. So if our leading variables have the same coefficients, if our leading variables are equal, so both of these values, they're both to the power of 2, our answers are their coefficients. So Bobo is bigger on bottom. That is y equals 0. So if it looks something like this, we have 4 divided by x. There is no x on top, so it's like saying it's x to the 0, and here we have x to the first power. So it's bigger on the bottom because this x is bigger than this x. So if we have that, that means our horizontal asymptote is going to be 0. Over here, I forgot to write y is equal to 2 over 5, sorry. And then Boat2 means bigger on top is undefined. Undefined. Sorry, I wrote that. Oh, gross. I've been writing so cute. Oh, well. And then, so this one would look something like 6x squared divided by 2x. Even though this 6 is bigger, we're not looking at that 6. We're looking at the leading the powers of each x. So it's bigger on top because here we have a 2 and here we have only 1. So when this happens, our answer is y is undefined. And undefined is this symbol right here. So let's come back to that. I know we just skipped around, but it's a review. We're going to be jumping all over the place. So with that in mind, let's take a look at our leading variables. So we have 6x over x. So is that Betsy Bobo Boat2? Both of them are equal, so that's Betsy. So bottom equals top is our coefficient, so y is equal to 6 over 1, which is the same thing as y is equal to 6. In our range, we're going to go ahead and fill that in with it's y except at our horizontal asymptote. So we're already at 25 minutes. I'm gonna just hurry it up along. I know you can watch this on your own time, but it's just if you wanted to only watch it in class, we only have 45 minutes. So right here, we're gonna do vertical asymptote first. So it's our vertical asymptote set equal to 0. So that means our vertical asymptote, we don't have to solve for x or anything, is that. Oh, I didn't box this one in. I didn't signify it right here. So that means our domain is everywhere except at 0. Horizontal asymptote, our leading variables, 7 over x. Bigger on top, bigger on bottom, or equal. Bigger on bottom, Bobo. So y equals 0. So that means our range is everywhere in y except at 0. Let's do this last one. So vertical asymptote, set our denominator equal to 0. So x is equal to -3. Means our range, our domain is everywhere except at -3. Horizontal asymptote, leading variables, 5x squared over x. Bigger on top, bottom, or equal. Bigger on top is BO2, so y is undefined. How fun. Don't worry, so just to keep it consistent with these three, range. Don't worry about range when we get to undefined, because that is something else, something different. So let's worry about something else. We are not gonna do this one. This one has too many problems. We're not gonna deal with that right now. Let's talk about this one. Now what we are going to do is we're going to graph it. So remember, I didn't say it had to be too pretty of a graph, I just want the general idea. So here we go. Vertical asymptote, set equal to 0. X minus 3, oh, I already said it. X is equal to -3. Right away, go ahead and draw it. If you're color coding, that's even better. Go ahead and draw it right now. So 1, 2, 3. This is my vertical asymptote. Man. This is my vertical asymptote. All crooked, but it's there. Horizontal asymptote. 2x over x. Bigger on top, bottom, or equal. This is Betsy, it's equal. So y is equal to 2. So horizontal, left and right. Don't worry about holes. Don't worry about domain and range for this one. We're not worried about that right now. So now a question is it negative? Am I flipping it? No negative, so I am not flipping it. So now I just have to draw it. And remember, my graph has to be somewhat close. So it is going to be approaching these two asymptotes. I could ignore this line, but it's going to be approaching these two asymptotes. Same thing on this side. Approaching these two asymptotes. This is what I want. This is something of what I want. Okay. Let's do that again really quickly. Again, we're not going to do domain and range. So vertical asymptote. Set that equal to 0. So my vertical asymptote is at -2. Oh wait, was this one supposed to be at negative? Yeah, it was. Horizontal asymptote. Look at leading variables. -2x divided by x. Bigger on top, bigger on bottom, or equal? Equal, so that is Betsy. So this is y is equal to -2. Do I have a negative? Yes, I have a negative. So this means I'm going to flip across x-axis. So remember, if it was not flipped, it would be something along these two. So now that it's flipped, it's across the x-axis. So approaching both asymptotes. Approaching both asymptotes. Okay, moving on. So remember the parent function that I mentioned before. So here it is again. That's okay. So I want to write all these transformations out so we can see it pretty easy and pretty clearly. So let's take a look. That a, my a value is at -1. Remember, if it's negative, it tells me that it flips. I'm not going to write all across x-axis like the other one, but it flips, right? My h is telling me what? It is 2. That means it's going 2 to the right. I know it sounds weird because usually when it's a +2, it's going to the left. Wait a second. It's a +2. But it's the opposite. So it has to be, oh man, I wrote this wrong. All right, let's move on. So K is going to tell us up or down. So this is 3 and this is 3 up. So with this in mind, we're going to go ahead and say, hey, let's write all of our vertical and horizontal asymptotes. So remember, this bottom, our denominator, is going to tell us what our vertical asymptote is. So set this equal to 0. So x plus 2 is equal to 0. So that means my vertical asymptote is that x equals -2. Oh, I switched colors. Oh no. X equals -2. So I was right. It was left. I was right that I was wrong. So it's 2 to the left. And horizontal asymptote. It doesn't tell me with this equation necessarily, but we now know it is at y equals 3. No, it's not. Man, I am not on it. Horizontal asymptote is my leading, oh, it's because we can't do horizontal asymptote because it's in this equation. So we would want to do this, but since we have a plus and minus right here, it's going to be a hot mess. But this is what I want you to write, basically. Yes. So let's, we're not actually going to do numbers 17 and 18 because they're worded interestingly. And then we're not doing 19 or 20. So we're going to do 21, and we're not going to do 22. So we can use all this space for these two questions. All right. So for 21, we are subtracting. This is from the last unit, so we are subtracting. What I want to do is combine, get the LCD, make sure that they both have the same denominator. Clearly, they do not. So what we have to do is factor. We got to do it. Don't. I know you're crying in the background. Please don't. So factor this A times C method. A times C. I'm going to write it up here because I have all this space. A times C is 8. What times factors of 8? 1 times 8, 2 times 4, and that's it, right? So I'm going to go ahead and write that equation up here. Which factors add or subtract to give me b? 2 and 4. I'll go ahead and write those. Put my x's in front. Sign of b goes to the second parentheses. Then positive times a positive. Sign of b times sign of c is a positive. Okay, let's move on to the next one. So I have 3, and I have to do a times c, so a times c is 6. 1 times 6, 2 times 3. Which ones add to give me 5? 2 and 3. If they were subtracting, it would be 1 and 6. Sign of b goes to the second parentheses. Positive times a positive is a positive. Now that I have an idea of what they are both missing from each other, I know this fraction is missing a x plus 4. This fraction is missing. Oh, so what you do to the top, you do to the bottom. And on this side, we are missing an x plus 3. So I'm going to go ahead and say, hey, now we have the entire fraction all good to go. Right? We have the same LCD, but we have to combine like terms and put everything together. So 4x times x plus 3 minus 3 times x plus 4. This is great, but you guys are better than that, and you guys can definitely do that and, you know, make it prettier. So we're going to go ahead and factor that out. So 4x times x is 4x squared. 4x times 3 is plus, nope, that is, I make mistakes too, 12x minus 3x. Remember, this negative goes to both, and this is also minus 12. Same denominator. Combine like terms, so I have 4x squared, 12 minus 12, 11, 10, 9, so plus 9x minus 12. Now it's prettier. All right, the last one, so we can round it up to 45 minutes. Last one, right here, number 23. Same idea. We want to get the same denominator. We don't have the same denominator. And we want to get what x is. We want to know that value. So what I'm going to do is I'm going to multiply by its LCD. This x, we want to have a combination of everything. So we want to have 3 times 4 times x. This is our LCD, right? So I'm missing a 4 here and a 3. This I already have an x, this fraction. So I'm just missing to multiply by 3. And this fraction, 4 and x. Right? So once I finish that up, multiply everything so it could look prettier. That's 4x divided by 12x, because 3 times 4 times x, minus 3 times x minus 6 over our common denominator. And 4 times 3 times 6, 4 times 3 times 2 is 24 for our same denominator. Do we have the same denominator? Yep. So what I can do now is I can focus just on my numerator. So I have 4x minus 3 times x minus 6 is equal to 24. I'm going to go ahead and factor this out. So I have 4x minus 3x plus 18 is equal to 24. Combine like terms. So I have 1x plus 18 is equal to 24. X by itself, minus 18, minus 18. So x is equal to 6. And we're done. This is it for the review. So if you didn't write on the back what our little notes are, this is it. Good luck tomorrow.